In this section, we're going to look at multiplication rules. Last section, we looked at addition rules, where we're selecting one event, and there were multiple ways that it could actually occur. Now, when we talk about multiplication rules, we're talking about multiple events. We're talking about, for example, rolling 6 and then rolling a 2. Selecting a green marble and then selecting a blue and then selecting a purple marble, for example. When we talk about independent events, what we're talking about is events whose probability of occurring is not affected by the outcome of the first or other events. So when we talk about independent events, we might be talking about an event like, for example, rolling a die. If I roll a 1 on the first die, rolling a 1 or a 2 or a 3 on the second die is not affected. Flipping a coin. Dependent events, the opposite of that. In this particular case, we're talking about events where the outcomes do affect each other. So in this particular case, we might be talking about selecting a card from a deck and then dealing another card from that deck. Well, if I have 52 cards in the deck to start, after I've dealt one card, there's only 51 cards. For example, if I go to select a jack and jack is dealt, it's a 4 out of 52 chance of occurring. But if I want to deal another jack, there's only 3 jacks left in the deck and there's only 51 cards. So that would be a dependent event. The multiplication rules. So we have 2 rules here, and these are our 2 rules right here. When we talk about these 2 rules, what we're focusing on is the idea the top one talks about independent events, where the one on the bottom talks about dependent events. Now notice what we have over here. This is referred to as B given A. So this would be the probability that B occurs given that A has already occurred. And this is called our conditional probability, and we'll look at that more in a second. So what is conditional probability? Well, we just kind of talked about it. If we refer to conditional probability, it's the probability of something occurring after we know the outcome of the other events. For example, if I want to look at the probability of selecting a jack from a deck of cards, we know that probability is 4 out of 52. But if I want to select a jack after a jack has already been selected, in this particular case, there's only 3 jacks in the deck and there's only 51 cards. So the probability in this case is affected by what has already happened. So when we talk about conditional probability, the probability of A given B or B given A, and remember we write that, this would be the probability of A given that B has occurred. This is our conditional probability, and this is when we talk about dependent events. We're also going to see keyword at least. I might say to you, what's the probability if I flip 5 coins that at least one of those is a tails? Well, think of that. If I say at least one tail, basically what I'm saying is this covers 1 tail, 2 tails, 3 tails, 4 tails, and 5 tails if we're flipping 5 coins. What doesn't it include? It doesn't include 0. So if we knew the probability of 0 tails, that would be the complement. Remember that term, complement? If we know the complement of an event, then all we have to do is subtract that from 1, and this, which is the probability of getting 0 tails subtracted from 1 is going to be equal to at least 1 tail. Well, let's look at 3 examples quickly. First of all, let's look at an independent event, in this case rolling a die. Well, the probability of rolling a 6 is 1 out of 6. Since these are independent events, we know that rolling a 6 on the second die is not affected by the first die, so we just copy down the same 1 out of 6. We multiply them together, we end up with 1 out of 36. So there's a 1 out of 36 chance that I'm going to roll a 6 followed by another 6. If we look at a dependent event, an example might be dealing cards. There are 4 queens in a deck of 52 cards, but once I deal that queen, there's still 4 jacks in the deck, but now there's only 51 cards. This is the conditional probability that we just talked about, because the outcome of dealing a jack is affected by the fact that there was already a queen dealt. Well, now I'm just going to multiply these two numbers together. And if I want to put it as a fraction, which is perfectly fine, 4 over 663. Or if I turn it into a decimal, which is also okay, 0.006. So this is a likelihood of me dealing a queen followed by a jack. What if I want to flip 3 coins? What's the probability that I will flip at least 3 heads? Well, this is going to be the probability that I flip 0 heads. Subtract that from 1. Well, if I'm flipping 3 coins, the probability that I flip 0 heads is 1 outcome out of 8. So there's a 7 out of 8 chance that I'm going to get at least 1 head. 1 head, 2 heads, or 3 heads when I flip 3 coins.